All right, good to see you guys again. Welcome back. We're going to be adding and subtracting radicals in this one. We've done this a very little bit. So the biggest thing, and I've told you guys before, and I think the past video when we were multiplying, they have to have the same radical, and now we'll see that they have to have the same degree in order to add or subtract them together. Sometimes we have to simplify in order to see if they do have the same radical, but they have to have the same radical in order to make that work. All right, so with this, I'm going to add or subtract each expression. I have root 3, I have root 3, so what I'm going to do is I essentially have 5 root 3's plus 7 root 3's to give me 12 root 3's altogether. That's it. You just treat them like variables. All right, so here, let's see if this is also a root 3 over here, because I know this is 16 times root 3. So this is the same thing as 4 root 3 minus root 3. All right, so that gives me 4 minus 1 is 3 root 3's altogether. And if you're curious how I'm simplifying these things, what I do is I think of the squares in my head. You guys should have done this in Algebra 1. You should have done this in geometry. Shouldn't be the first time you're seeing it. 7 would be 49. 8 would be 64. So I think about these, right? These are all the perfect squares. This is 2, this is 3, this is 4, 5, 6, 7, 8, and it goes on from there. I mean, you have 81 is 9, 100 is 10, 121 is 11, 144 is 12, so on and so forth. And I see which one of these square roots divides nicely into that 48. The biggest one that does is the 16, so I made that square root 16 times square root 3, and then I can simplify that because I know the square root of 16 is 4, so I have 4, and then I left the root 3 on the inside. So moving on. Try to remember, you may want to write this chart down, reference it as we go. So like for the next one, I see some big numbers. I see square root of 28 and I see root 32. So I automatically am thinking about these numbers, and thinking about which one will go into it. So for like 28, I know 4 will divide evenly into it, because 4 times 7, that's probably all it's going to be because 7 is a prime number. 9 won't go in, 16 won't go in, 25 won't go in, 36 is too big. So I would think of this as root 4 times root 7. 32, I know I can go in as 16, and that's the biggest I can do there. So that's root 16 times root 2. So then I can simplify this. I'll leave the 2 root 7 alone. And then I have plus, so notice I'm bringing out 2. This is 2, but there's already a 3 there. So 2 times 3 is what I do with that, and I make it 6 root 7. And then this would become minus, so minus 4 root 2. Now I can only combine the ones that have the same square roots. So the root 7 and the root 7 can combine. So I have 2 of those plus 6 would give me 8 root 7's. And then I'm going to leave this one alone because it has a different square root. So minus the 4 root 2, and that's it. All right, moving on. We can do the same thing. As long as they have the same exact square root, I can combine them. So I have 3 root x's plus 15 root x's minus 4 root x's are all the same. So 3 plus 15 is 18 minus 4 is 14 root x. And that's it. All right. Part E here. So again, these all have root 3's, but notice these ones have an x associated. So that's what I meant by the same degree in order to add them. This one has 0 x's, so I'm going to write this in standard form where my x's come first. So I have negative 4x plus 6x would give me positive 2x root 3, and then plus that 6 root 3. You guys could also see this. They could factor out the root 3 such that this becomes 2x plus 6. So that root 3 would multiply to both of those and give us the same thing that we had all throughout there. Could see it either way. Both means the same thing. All right, with part F here, notice I have an a cubed. So with that a cubed, there's 3 a's. So that means there's one group of 2, and then I still have one left on the inside. So this will become 3a root a plus 5a root a minus 9a root a. So they all have the same degree, and they have the same radical. So all of those are the same radicals. They're all to the first power, so they all have the same degree, so I can combine all of those things together. So this becomes 3 plus 5 is 8, minus 9 is negative 1, so I have negative a root a as my solution. That's my answer. All right, part G, and we're done. Oh yeah. So if I have x cubed, again, that's going to be the same. So three of them. So I can pull out one group, and I still have one left on the inside. So I know this will at least turn into the square root of x squared times x. And this 18, think about that, that's root 9 times root 2. Right? Because I know the square root of 9 is 3. I don't know the square root of 2, even though it's 1.4. I have too many things memorized. 32 is root 16 times root 2. 8 is root 4 times root 2. And 50 is root 25 times root 2. All right, so this 18 becomes 3. I know I'm pulling out an x, root 2x, plus, so plus, 32 is 4. I have the 2 left on the inside. Notice I have 3 x's there, so I'll do the same thing. X root 2x, and then minus. So this one, I already have a 3 on the outside, but I'm pulling out a 2. 2 times 3 is 6. X cubed, so I have an x and 1 left on the inside. So root, bring that 2 on the inside as well. And then 25 is 5, so 5 times 4 is 20, so plus 20. I have x cubed, so that is the x root x, so x root 2x. Now, x to the first, root 2x, x to the first, root 2x, x to the first, root 2x, x to the first, root 2x. So they're all exactly the same. Yes. So that just means I can combine them all together. So I have 3x plus 4x is 7x, minus 6 is 1, plus 20 is 21x root 2x. And that's it. All right. Hopefully this video was helpful for you guys. Again, another Blue Monkey to give you guys some support. Please, please, please let me know what questions I can answer for you guys along the way. I'm here for you, I promise. Just shoot me an email and I'll respond. All right, I'll talk to y'all soon. Bye.